Alright, so we are starting Algebra 2. So the very first section of Algebra 2, finally starting that up. It's in Chapter 1. This is equations and inequalities. And 11.1, this is real numbers and number operations. So subsets of real numbers is what we're going to talk about. And the first subset of real numbers is whole numbers. And we need to sit down and think what a whole number was. And some of you, I hope, remember from Algebra 1, but just in case you don't, whole numbers start at 0 and they work their way up from there. So 0, 1, 2, 3, 4, and on the whole way up. And next up we have is integers. And integers are numbers that are both negative and positive, and they also contain 0. But integers do not have fractions, they do not have decimals in them, so keep that in mind as well. They do not have weird square root signs in them either. All they have are negatives, positives, and 0, and they go on forever in either direction. Rationals. Rationals is fractions. Rationals are ratios. Rationals are decimals. But the decimals must terminate or repeat. So what that means is they are basically ending. So for example, we have 3/4. We have negative 5 over 1. Even though negative 5 over 1 will reduce to negative 5, it is still a fraction, so it is still a rational number. 0.75 is a decimal, and 0.333333333 keeps going on forever, but it's the same thing over and over and over again that repeats. That is the fraction 1/3, so either or, they are both rationals. And irrational numbers, they are real numbers that never end. Okay, so for example, pi is an example of that. Later, way down the line, we'll get to e. E is a number like that as well, the Euler number that doesn't end. And square root of 2 is another example of that.
So when did you know you wanted to be a model?
I guess it would have to be the first time I went through the second grade. I caught my reflection in the spoon while I was...
So, example 1, square root of 12. So I just want to graph square root of 12 is really all I want to do. Just want to graph the square root of 12. So when I go to do this, the square root of 12, I put it on my calculator. I typed in square root of 12 and I got approximately 3.46. So I go over here on my number line, and 3.46 means it's in between 3 and 4. And it's pretty close to half, so I'm going to put it right about in there somewhere. There's 3.46. So example 2, a nice simple one here to graph again as well. Graph negative 4 and graph 3. Well, here's negative 4, so I put a dot there at negative 4. Here's 3, so I put a point at 3. So here are the elevations of 5 locations in the Emerald Valley, California. El Mario is 135 feet. Curly is negative 93 feet. Gieselman Lake is 162, negative 162 feet. Moss is negative 100 feet, and Orita is negative 92 feet. Order the elevations from lowest to highest. The lowest number to highest. Now, here's the tricky part. Here's the catch. Most people just want to assume that low to high. So the lowest number is that I see 92. So we'll start with 92. But you have to remember, negative numbers, right? If you remember a number line, 0 is in the center and it's negative 1, and the lower the number that's negative, the lower the negative number, it actually looks bigger, right? The negative actually looks bigger the farther down it is. So in this example, the actual truly biggest negative number is negative 162. That's the Gieselman Lake. Next up is the Alamarillo, which is negative 135. Then negative 100, which is Moss. Then Curlew, which is negative 93. And Orita, which is negative 92. So which locations have below 100 feet? So below 100 feet. Below 100 feet would be those two up at the top. So properties of addition and multiplication. So you have this. Let's fill that in. We have the property, and we have the addition and multiplication column. So the closure property is basically just saying a plus b is real. What that means is if you add two numbers together, you'll get a real number. And it's the same if you multiply. If you multiply two numbers together, you'll get a real number. The commutative property says if you have two numbers and you basically add them together, you can add them together in reverse and get the same thing. So a plus b equals b plus a. So for example, if we had x plus 3, you get the same answer as 3 plus x. With multiplication, it's the same. A times b equals b times a. It doesn't matter which way you multiply, you'll still end up getting the same answer. So x times 4 is the same as 4 times x, and both those actually are just 4x. The associate property says that if you have three numbers that you're adding, right, it doesn't matter if you order the first two and group them together and add them first, and then add the last number, or if you add the last two in grouping first and then the first one, either way you'll still get the same answer. So what we're saying here is if you do x plus 4 then plus 3, it's the same as saying x plus 4 plus 3. Either way you're still going to get x plus 7. Well, it's the same with multiplication. The order of multiplying doesn't matter. So if I have these two grouped together first times c, it doesn't matter if I do a times those two at the end. So 3 times x times 5 is the same as me saying x times 3 times 5, which is 15x. Either way you slice it, you're going to get 15x. Identity property for addition is a plus 0 equals 0. And what that basically is saying is you have some number plus 0 is going to give you that same number back again. So 7 plus 0 is 7. However, the identity property for multiplication is a little different. The identity property means getting the same number back out. So 7, when you add a 0 to it, gives you the same 7 back. But what number will give you the same number back in multiplication? That's actually a 1. So this is a times 1 equals a. So an example of that would be 5 times 1 equals 5. And the inverse property is when you add this two things together and one's negative, one's positive, it'll be 0. So 8 plus negative 8 is 0. And the inverse for multiplication is how do you get a 1? Well, when you multiply one item by its reciprocal, you will end up getting 1. So 9 times 1/9 equals 1. So when we come back, we will finish up on 1.1.